Hi friend, you are welcome back to my channel. In today's video lesson, we shall be learning about optics shortcut formula. And specifically for today's video, we shall be looking at the formulas that applies to refractive index. And the symbol for refractive index is small n. So without wasting time, let's get started immediately. Now using the formula we get from Snell's law, for finding refractive index, you can say refractive index n is equals to sine I over sine r. This formula is gotten from, like I said, Snell's law, right? This formula is gotten from Snell's law. Now you may want to ask me, what does I stand for and what does r stand for? Okay, this is it. I here stand for the angle of incidence, right? So if you were giving angle of incidence and then you were giving r, which is the angle of refraction, okay, you can use this formula to get your what? You can use this formula to get your refractive index, okay? You can use this formula to get your refractive index, provided you are giving I and r. Now, what if you were not giving I and r? Okay, let's say the question was pertaining to a glass prism. If the question was about glass prism, okay, what is the usual formula to use? N is equals to sine in bracket A plus D over 2 close bracket over sine A over 2. Guys, this is the formula to use. Okay? A plus D divided by 2. The value you get, take the sign of that value. A divided by 2. The value you get, take the sign of that value. So the value from this will be divided by this. That will give you your refractive index. Now you may want to ask me also, what does capital A and D stand for? Now A here stands for the refracting angle of the glass prism. It stands for what? The refracting angle of the glass prism. Okay? Now what does D here stand for? It stands for minimum deviation. Minimum deviation. So be taking note of all this formula that applies to refractive index. Okay? This specifically is for glass prism. Glass prism. Now we know this. What if it was a wave? What if it was a wave traveling from, let's say, vacuum to a medium? What is the formula to use? Now if you are given the speed of the wave in vacuum and in the medium, to get your refractive index, you will say N is equals to C over V, where C here stands for the speed in vacuum. Speed in vacuum, and that we know is fixed. The speed of light in vacuum, or the speed of electromagnetic wave in vacuum, is a fixed value. We call that the speed of light. And what's the value? 3 times 10 raised to power 8 meter per second. So C here is a constant. It is the value of the speed of light in vacuum. And that value is 3 times 10 raised to power 8 meter per second. While V here will be the speed in the medium. Okay, speed in the medium. Now what does this mean? As light is traveling from vacuum and hits a medium, that light will be refracted. So we can calculate the refractive index of that light with respect to vacuum using this formula. Okay, so we already know the value of this. If we're given the value of the speed in that medium, we can get our refractive index. That is where this formula applies. Now what if we're not given in terms of velocity, or we're given in terms of wavelength? How will you now calculate your refractive index? The formula to use will be N equals to lambda, where lambda stands for wavelength. Lambda, this symbol, is the symbol for wavelength. So what is the formula we will use? Refractive index is equals to lambda for vacuum, okay? That is wavelength in vacuum over lambda in the medium. I hope that is clear. So if you were given the wavelength for the two different medium, vacuum and then in the medium, you can get your refractive index. I hope this is clear. Like I said, this symbol is called lambda. It stands for wavelength. So this is wavelength in vacuum over wavelength in the medium. If you do that, you get your refractive index. Now, sometimes you might not be giving wavelength, you might not be giving velocity. You might be giving what they call critical angle. Okay? How do you now find your refractive index when you are giving critical angle? Now, guys, this one is simpler. The formula is refractive index will be equals to 1 over sine C, where C here stands for critical angle. Critical angle. So this is what we will use to get our refractive index. Now I want to emphasize on something regarding this. Now you use this formula if and only if the second medium is air. I repeat, this formula applies if and only if the second medium is air. Now what if the second medium is not air? Okay, because apart from air, you cannot use this formula. If the second medium is, let's say, glass, let's say water, you cannot use this formula. If the second medium is not air, so let me do it like this. Okay, if the second medium, if medium 2 is air, that's when you can use this formula. Now what if medium 2, the second medium, is not air? What is the right formula to use? Guys, this is it. N1 over N2, okay, is equals to, you have, watch out, 1 over sine C, alright? If the second medium is not air, this is the formula we are going to make use of, okay? Where N1 is usually the N, refractive index of medium 1, alright? Of medium 1, and N2 is the refractive index of medium 2. Be taking note of all these important formula. They will save you a whole lot of stress. Okay? If the second medium is not air, you will use this formula. So I'll write if medium 2 is not air. Alright? So this is for that. This is for that. So now we've talked about for glass, we are giving angle of incidence and angle of refraction. Now, what if you were not giving what they call depth, in terms of depth? You were giving in terms of depth, okay? An object is tossed into the water. The object appears to be at a certain depth. Calculate the refractive index. Now, this is the formula to use. N is equals to arrow over A. Now, what does arrow stand for? And what does A in this case stand for? Arrow here stands for the real depth. Real depth. Real depth. The real depth. Okay? While A stands for something else. A stands for apparent depth. Apparent depth. So if you know this, you are good to go. Now sometimes for this very case, they might not give you the apparent depth directly. Okay? They might tell you that the object was displaced from the real depth to another depth by a certain value. So in this case, you are given displacement, not apparent depth. Listen and listen good. If you were told the object appears to be at a certain depth, that is apparent depth. But if you were told the object is displaced by, let's say, 3 cm, okay, that is displacement, not apparent depth. And if that is the case, what is the formula to use? Watch out. It will be N equals to arrow over arrow minus D. Guys, this is the formula to use. Where D here stands for what? Displacement. D equals to displacement. Displacement. So I hope that is clear. I hope that analogy is clear. An object if the object appears to be at, let's say, 10 cm, that is apparent depth, because they use the word appears to be. Apparent. I hope that's clear. But if then I said if the object is displaced by, okay, that is displacement. The value that follows will be for your what? Displacement. Mind you, they will give you the real depth, they will give the real depth. So either ways you can get your refractive index. Now guys, take note of all these important formula. You can take a screenshot. And these are the important formulas that applies to finding refractive index. And I trust you find the video helpful. I will see you guys in the next video.